Hello, SSEF judges. We are pleased that you have taken the time to judge our project. Our project title is Effects of Sugar on Lumbricus terrestris casts, in which we sought to see if sugar level had an effect on red wigglers or Lumbricus terrestris, a common type of earthworm. In more recent years, people have begun to move to more organic lifestyles, buying locally or home-growing produce. In fact, more than 49% of Americans had tried to grow plants at home in 2018. Worm casts are the worm's fecal matter, the very thing that helps them make plants grow. The NPK scale is a scale that measures the levels of nitrogen, phosphorus, and potassium in soil. Worm casts on the NPK scale rank very low at a 1, 2, 0 rating. While synthetic fertilizers rank very high on the NPK scale, the effect is greatly exaggerated. Plants do not absorb all of the synthetic fertilizer's nutrients, which then can sit dormant waiting to be carried away by water. Worm casts, however, do not depend on the NPK scale, but rather the microbes produced after digesting organic material. Further, factory-made fertilizers can be harmful for the environment by mixing several nitrates and minerals into local lakes and rivers, causing poor living conditions for aquatic life. The farming of worm compost, also known as vermicomposting, is a growing community that promotes recycling old food and table scraps to the worms to produce eco-friendly fertilizer. As of now, however, there has not been a set food type in which to feed the worms for maximum result in the worm cast. This study sought to find if different sugar levels when fed to the worms had any effect on the efficiency of the casts produced. The environment is a very important part of our state, along with our rivers and oceans. Locally, in our own plant city, there is nothing but growing fields, all of which use trucks to spray copious amounts of harmful fertilizer onto the plants. The heavy watering associated with the growing season picks up the excess fertilizer, which drains into our rivers and aquifers. This can be harmful to the aquatic life, as the minerals present will poison them. We wanted to find a more environmentally friendly way to support our growing fields and help the environment.
To conduct the experiment, sugar levels had to be chosen. This was done by selecting fruits that had varying levels of sugar. The three that were chosen were mango, watermelon, and tomato. Mango having the highest sugar concentration, watermelon at a medium, and tomato at a relative low. Each fruit became a group, with 5 pots per group. A fourth group was added, this being the control group, to which the other groups could be compared to find a statistical difference.
Our null hypothesis for the experiment is different levels of sugar will show no statistical difference in the efficiency of the casts produced. To accept or refute this, the data collected for the fruit groups was compared to the control group to see if a statistical difference was present. Our alternative hypothesis is different levels of sugar will show a statistical difference in the efficiency of the casts produced.
In our procedure, one worm was placed in each of the pots excluding the control group. Each pot was designated with a fruit and was fed a blended form of the fruit to allow it to seep into the soil. The worms were fed every 2 days. Poppies were planted to grow in each pot, and the plants were watered on the same day that the worms were fed. The growth of the plants was measured every 2 days and recorded. This would allow for comparison to show a statistical difference in the efficiency of the worm casts.
During the experiment, the worms did very well and were all placed on the ground after the experiment. The tomato group by far did the best and was the first to germinate. 2 days after the first germination, however, the entirety of the plants had at least germinated. Tomato at the beginning grew very rapidly and developed thick purple stems. The control group, while nowhere close to the tomatoes, did fairly well and developed small purple hues to the stems. Mango and watermelon did very poorly. The average growth rate for both was around 0.1 centimeters. The stems seemed very weak and the plants did not grow any purple hue at all.
The data collected in the study shows that we can successfully refute the null hypothesis by comparing the control group to each of the fruit groups using a t-test. The only group to show a statistical difference was the tomato group. This shows that lower levels of sugar when fed to the worms will improve the efficiency of the worm casts produced. A step further would be to say that the higher levels actually harm the efficiency of the casts. The constant high level of sugar diet for the worms may have had a negative effect on the digestive rate of the worms and may have had a negative impact on their health.
Some problems the researchers encountered while working on the experiment was the lack of a protective tarp over top of the worms in the pots. The same screen that was used to line the bottom of the pots was also used to cover the top. This ensured both the protection of the worms from predators and from the worms escaping from the top. Secondly, food delivery became an issue. The pulpy fruits, this being tomato and mango, would not easily go into the soil. and instead sat at the surface. This was realized quickly, however, and to rectify this, 500 milliliters of water were added to each ration to dilute the food. This allowed for the food to seep deeper into the soil, where the worms would potentially be. Lastly, a possible negative factor may have been the colder weather during the latter days of December, as worms would not be less active in the cold.
The information found in the study has multiple real-world effects. The research has formed the basis for what to feed worms in order to produce the maximum product. Local levels of farming can benefit in worm casts as they provide greatly effective fertilizers that are cheaper than store-bought alternatives. Lastly, this is a step away from harmful artificial fertilizers and a step towards a healthier environment. An interesting idea for the future of this project, we designed an experiment to test to see if there was a threshold in which sugar was most effective in, a Goldilocks zone, if you will, where there might be too much or too little. Using the results from the current experiment, a range of fruits would be chosen to zoom in on the effective sugar range and decide a more specific result than the current experiment that only features high, medium, and low levels. This would allow for a more accurate report that would further the efficiency of future vermicompost.
This concludes our presentation. We are again glad that you have taken the time to judge our project, and we hope we are a strong consideration when you make your decision.